Before we look at the slides for section 8.1, I want to give an overview. So the goal here is to give an estimate for the population mean mu. We don't have that. But what do we have? Well, we can always take a sample. So let's take a sample of, let's say, size n. And with that sample, we can get a sample mean. So we can find any sample's mean, no problem. So what the idea is to use this to estimate the population's mean. Of course, we're going to be a little bit off. So the idea is we're going to say, well, I don't know what the population mean mu is, but it's between these two values. Okay, so it's between this and this. So what we're going to do is we're going to say, well, I don't know what the value actually is, but so there's going to be some difference between what I guess and what the actual value is. We call that our margin of error. Of course, we could guess too big, we could guess too small, so we could also use just the absolute value. So what we're going to want to do is go back to our confidence intervals. And we would like to say something like, I am 98% sure that mu is between, let's say, x bar A and x bar B, between two values. So we'd like to say a sentence like this. I'm very sure, or I could be 98% sure, I could be only 70% sure. So this 98%, this is going to be our C, our confidence level. So how do we go about finding this? Okay, well, we already know something from our confidence intervals. Let's look at those. So let's say here's x bar. And let's say we want to be 98% sure. Well, we know what these should be. Let's see. Well, we looked before, we saw for C equals 98%. We should have Z sub 98, or 0.98 I should say, was negative 2.33, and over here 2.33, positive. Okay, we're trying to get a value centered at the mean, except our mean here is x bar, but Z is Z. That doesn't change it. So the idea is now, what values would this be? Well, we know that Z is x bar minus mu over sigma times the square root of n. So for this case, we could say ZC. We're talking about this particular one. So we saw on the other slide that x bar minus mu, the numerator, is our margin of error. Okay, so let's see. If I would like to get just the numerator, I have to get rid of this denominator. I'm going to multiply both sides by sigma over the square root of n. So that means I get ZC times sigma over the square root of n, and this is x bar minus mu. Great. Okay, so this is going to be our error. I'm using ZC here to be more general, but in this particular case it would be C is 0.98, and so ZC would be 2.33. So we don't know exactly what our mu is, but we're trying to guess. So we're going to say that our mean x bar, okay, so this is, we can go up a little bit or down a little bit. So it's going to be x bar plus the error and x bar minus the error. That's going to be our range. And we're saying that our mean is going to be between there. So I hope that makes sense. What we're looking for is we're looking for an interval, and we're saying that our mean is in the actual population mean mu is in this interval.